In today's video, I'll be showing you some tips and methods to use in diagnosing and troubleshooting your furnace board. The difficulties, especially when you're in the field dealing with a specific issue, troubleshooting, is most likely you're going to be doing this alone. So if you have to go into the attic, a lot of times you're going up the ladder, down the ladder, out to the condenser, back to the thermostat, back up to your furnace board. And this kind of eliminates that need of you having to just go up and down and unnecessarily having to turn the thermostat off and turn it on, cool, heat. This will kind of be a way for you to just basically jump your furnace board and test out each component individually. Especially if you find yourself in a situation where you're troubleshooting for a low voltage short, it's just very helpful just being able to jump the system here at the furnace board. So right now I did put electrical tape over my safety switch. Again, if this switch is not engaged, you can see here my LED light is in the on position. Once I take my tape off, that will remove any power going to my furnace board. Here we want to make sure that the switch is engaged, and this will send power to the furnace board. Now this basically is a safety switch. Usually if you have your panel, once you remove your panel, this switch activates in order to remove power to your board, to your furnace, to protect the technician who's working or servicing the unit. Here we have a switch on the wall. It may not be a switch, it may be an actual plug-in and an outlet. This is going to be your power coming directly from the circuit breaker. So here it's in the on position. You can see my LED light is on. Once I turn the switch off, this will remove any and all power to my furnace. We're going to turn our power back on. This will energize our furnace board. The LED light is on, and that indicates to me that I have 24 volts coming from my transformer to the board. Here, I just kind of bought these end leads. These are the Alligator Clips, and basically I took just one of the thermostat wires that I had laying around for the 24 volt and basically just tied them in. And basically what this is going to allow me to do is going to allow me to just jump the system up here using my Alligator Clips. Here you can see I have my W, Y, R, and G terminals and my wires that are running to them. So here, the first thing we're going to do is we're going to test our blower motor. So here we have our R, that's going to be our 24 volts. And here we have our G terminal. The G is going to be your blower motor. Let's say right now I received a call, I inspect the system, and I see that my blower motor is not running. The first thing we're going to do is we're going to want to inspect the system. So instead of going downstairs and turning the thermostat to the on position, what I'm going to do is I'm basically going to jumper it out here, and this will just allow me to troubleshoot without having to go back and forth. I'm going to turn my power coming in off. Here I have my Alligator Clip on my R terminal, that's my 24 volts, and my G terminal, that's going to be for my blower. And basically this is going to cause it to bypass my thermostat. Here is my thermostat, and you can see it's on the off and auto position. So right now my thermostat is not sending a signal to my furnace board and calling for heat, cool, or for the fan. I'm going to turn the system on, and because I jumpered it here at the furnace board, I'm bypassing my thermostat and my blower should turn on. Now the reason this is beneficial is because right now we're going to troubleshoot our blower motor. Here I basically remove one of my leads for my blower motor going to the capacitor. This means that my capacitor is not energizing my blower motor, so it's almost acting as if we have a blown capacitor right now. What I would do if I received a call that the AC wasn't working and I pressed in my contactor, my compressor turns on, my fan motor turns on, I would obviously come to the thermostat, make sure that it's on the on position. If I listened and I did not hear my blower motor turning on, I would know that there's an issue. So instead of going up and down, back and forth, here I'm at the blower motor. I've jumpered out my R terminal and my green terminal. Right now I removed my wire from my capacitor, so this would act as if I have if I had a bad capacitor. And now I'm going to turn my system on, and you can hear my blower motor's trying to turn on. So I would know right away that I have an issue with my blower motor. What I would do is I would turn my system off. I would replace my capacitor. Here I reconnected my lead, and then basically I would turn the system on to see if my blower motor turned on. This would also allow me to test my terminals here at the furnace board. So here I have my 2 wires coming from my blower motor to my furnace board. If I remove those wires, that would allow me to test for 120 volts at the furnace board. Here I remove my wires. I have my multimeter tapping each lead coming off the furnace board where my blower motor was tied in, and you can see here that I have a reading of 120 volts. Here I tied my wires coming from my blower back to the board. Turn our system back on. This method is extremely beneficial when you're trying to find a short in your system. Right now, I've purposely created a short in my condensing unit, and right now what I'm going to do is I'm going to test the system. Now what happens oftentimes when you have an issue with a low voltage short, you can see here this is the fuse. The fuse is what ties into your furnace board, and a lot of times you'll find that when you have a low voltage short, if it's in your blower, your heat, or in your condensing system, you'll come back and your fuse will have the link in the middle broken, and you'll see some discoloration due to it popping. I've purchased what's called a resettable fuse, and basically instead of just replacing fuse after fuse trying to troubleshoot the system, what this does is it actually will pop and allow me to reset it without me having to replace the fuse. Now I jumpered my blower motor. I'm going to turn the system on here from my circuit breaker. I turn the switch on, and right now my blower should engage. Now I'm going to turn my switch off, and I'm going to move my jumper from my blower to my heat. Here I have my alligator clip on my R, that's my 24 volts, and on my W terminal, which is going to be my heat, I'm going to turn the system on, and the heater should turn on. Just remember, the heat's not going to turn on right away. Right now the blower motor's engaged. The heat's going to go through a check and balance just to make sure that everything is working properly. So after this, the inducer motor will turn on. It'll check the gas valve as well as the igniter. So it'll take some time, so just be a little bit patient. So right now, if I was troubleshooting my system and I had a short, I would know at this point my blower motor's working, my heater's working, so that would leave one option left. So here I put my alligator clips to my R, my 24 volts, and my Y terminal. That'll be for my condensing unit. Right now I have my unit in the off position here where my switch is. I'm going to turn it on, and because I created a short, that should cause my resettable amp breaker to pop. Right now I'm going to turn my incoming voltage off. You may have to wait a couple of seconds before you're able to reset your breaker. Once you reset it, right now I'm going to turn the switch back on. These are just some quick troubleshooting methods that I wanted to share with you. And again, if you're able to purchase this right here, it's about 10 or 12 bucks on Amazon. Great tool to have, especially if you're running into a situation where you're by yourself on the field. And just this method of jumping everything here at the furnace board will just help you as far as eliminating the cost and the time of extra labor on a job site. If this video was a help, if it was informational, please subscribe.